Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on Organic Chemistry 1 and just finishing up on some properties of alkynes. So previously we looked at the physical properties and preparation of alkynes. So for today we are going to be looking at the chemical properties. You'll notice a little bit of similarity between reactions of alkynes and alkenes, and then we will do a few questions. So one of the properties is burning or combustion. So alkynes usually burn with a yellow sooty flame or a luminous sooty flame in excess air to form carbon dioxide in water. So alkenes also burn with a yellow sooty flame. So you notice this is similar in both cases. This because they have very high carbon hydrogen ratio, and so they usually are unsaturated. So when you burn them, you see a yellow sooty flame. This information is important, especially when we are doing our qualitative analysis. So in the case of ethane, it burns in oxygen to form carbon dioxide and water. In excess, in limited amounts of oxygen, it can form carbon or carbon monoxide. So you see in the first experiment, it's forming a reaction with limited amount of oxygen, it forms a carbon and water, and also in limited amount, it can form carbon monoxide and water. But when it burns completely in air, it burns to form carbon dioxide and water. So it usually also undergoes addition reactions the same way as alkenes. So some of the addition reactions that it undergoes, and it majorly happens on the triple bond, which is similar to alkenes that most of the reactions occur on the double bond. But now in alkynes, you notice reactions will be twice faster than the ones that were in alkenes. So one of the addition reactions is hydrogenation. So we say that this reaction occurs in presence of nickel catalyst, but note the temperatures now are a bit different than those of um, alkenes, where we were using 180 degrees Celsius. Now we are going to use 200 degrees Celsius, and we are going to form intermediates. So the alkyne reacts first to form alkenes, and then it reacts to form alkanes. So during hydrogenation, two hydrogen atoms in the hydrogen molecule attach itself to one carbon and the other two to the second carbon, breaking the triple bond to double bond and then to single. So you can see an example is on propyne. You see it has triple bond. So the first bond is broken by introducing two hydrogen. You see one hydrogen has been introduced here and another hydrogen has been introduced here. And then finally the double bond is broken by introducing more hydrogen here and more hydrogen here. And then another process is called halogenation. Halogenation is an addition reaction where we add halogens across the triple bond. So the reaction in alkynes with halogens is faster than the ones that are in alkenes. So the triple bond in alkynes breaks to form a double bond and then a single bond. So the color of the halogen will fade as the number of moles of halogens remain unreacted decreases. So two bromine atoms, for example, when ethane reacts with bromine, so two bromine atoms usually add in the first carbon, and then while other two goes to the second carbon. So you can see the first, in this case, when we are reacting, this is a butane. So you see the first bromide atoms have attached themselves to the two carbon, and then in the next reaction, they attach themselves. So at the end of the day, we end up having four bromide ions in the reaction of four bromine atoms in the compound, and this is because it's attaching itself simultaneously. So this reaction is very simultaneous, as you can see, and you can see the reaction will be more faster in comparison to alkene. If you are using chlorine, you can see the chlorine first adds in the first two carbons, and then also finally it adds to the remaining. So another addition reaction is hydrohalogenation. So hydrohalogenation is the addition of halides to form hydrogen alkane and then hydrogen alkene and then hydrogen alkane. The reaction is simultaneous. So a triple bond in the alkyne breaks to form double bond and then single bond. So the main compound is the one which the hydrogen atom at the both at the carbon with more hydrogen. So it follows the mechanical rules that states that hydrogen adds the carbon that has greater number of hydrogens, and the halide adds the carbon with fewer number of hydrogen. So when we are doing this reaction, the first step of the reaction, this is what happens. So when you look at the second product, this helps us to follow the mechanical rule. So you see in this carbon, when you compare these two carbons, this first carbon has one bromine atom, this second has one hydrogen atom. So when we are adding next, we are going to put hydrogen where there's more hydrogen, and the halogen is going to go to the next carbon. That's why we are adding the hydrogen in this carbon and not in this other carbon. So that follows the Marconico's rule. Marconico's rule. And then finally, we look at some uses of ethine. So ethine is used in the manufacture of compounds like adhesives and plastics, and it is used in the oxyacetylene flame, which is used for welding and cutting metals. Uh, so this flame has been mentioned before in the uses of oxygen when we are doing ammonia. So that brings us to the end of the lesson. I hope you have been able to see some of the chemical properties of alkynes. You notice they have the similar properties with alkenes in regards to the addition reactions. And that's the reason why we say alkenes and alkynes are unsaturated. And when we come to qualitative analysis, you will notice you're going to be focusing on some of this reaction, the reaction like with oxidizing agent, reaction with bromine, especially when it comes to bromine. Remember, we said one of the tests for alkynes and alkenes which are unsaturated is use of bromine, which is yellow. So when you add a few drops or when you bubble these gases in bromine, they decolorize, telling us that they are unsaturated in nature. Remember, they are colorless, which is similar in all cases, both also in alkanes. So it is important to see how you can look separate. And we also said that for alkanes, they burn with a blue flame, but for alkenes and alkynes, you have noticed they burn with a yellow sooty flame, which is completely different. So in qualitative analysis, also this is one of the things that we are going to focus on, the way they burn in air and what makes them distinct. And we do not only carry one reaction in the analysis of these hydrocarbons, we do consecutive reactions that helps us to distinguish them from one another. So that's it for today. We are going to end the organic chemistry 1 at this point. So we're going to have an opportunity to discuss qualitative analysis. Check out the video on how to answer these qualitative questions, especially organic qualitative analysis, because we do have inorganic. Check out that and see how we answer questions in regards to the organic compounds. So see you in the next lesson as we start a whole new topic on nitrogen and its compounds. See you then.